In this video, we are going to be dividing polynomials. We're going to be using long division, which is probably the division you learned in elementary school, except for polynomials makes it a little bit more difficult. But the process is the same. So let's go ahead and review how would we do 60 divided by 4 using long division. 60 divided by 4. So the way I was taught is I'm assessing, can 4 go into 6? And if so, how many times? The answer to that would be 1. So I do 1 times 4, and then I subtract. 6 minus 4 is 2, and then I bring down the 0. So then I ask, does 4 go into 20? The answer to that is yes. How many times? 5. 5 times 4 is 20, and I subtract, and I wind up with 0. There's nothing else to bring down, so this is finished, and this explains that my remainder was 0. And so one thing to take from this is that because there was no remainder, 4 is a factor of 60. Also, 15 is a factor of 60. And of course, that means that 4 times 15 does equal 60. Here we have another example, but we do have some decimals. One way to do this problem is to clear the decimals out by, in this case, we just multiply by 10. So we're moving this to the right one, and we're moving this to the right one, and that'll take care of it. So we really have this division. And this process is all the same. Okay, so does 76 go into 3? No. Does it go into 32? No. Does it go into 321? Yes, it does. How many times? This can be sort of an estimate, a little bit of trial and error if you're not certain how many times 76 goes into 321. But I would do, since 7 is like 70 and we're going to 320, I would do 4 times, because 7 times 4 is 28, or 280. Let's see if that works. 4 times 6 is 24. 4 times 7 is 28, and then that 2. So we get 30. So 304. And I'm going to subtract, and 321 minus 304 is 17. And since 76 doesn't go into that, I know that I couldn't have squeezed another 76 into that amount. Does 76 go into, bring down your 4, 174? Yes, it does. Be twice, because 2 70s would be 140. So let's multiply this. 2 times 6, 12. You get your 1. 2 times 7, 14, plus that 1 is 15. And we're going to get 22. Bring down the 8. Does 76 go into 228? Yes, it does. How many times? I think this one's going to be 3. I think it's going to work out perfectly. 3 times 6 is 18. 3 times 7 is 21. Add the 1, we get 22. Subtract those, and you get a remainder of 0. So 76 is a factor of this, just like 7.6 would be a factor of this. And our quotient is 423. Okay, that process is going to be used for polynomials. Even though it does not seem like it, factoring is a form of division. Each factor goes into the larger polynomial evenly without a remainder, like we saw here and here. For example, take the polynomial 2x cubed minus 3x squared minus 8x plus 12. If we use factoring by grouping, we would find these factors, 2x minus 3, and then technically it would be x squared minus 4, but that's a difference of squares, which factors into these two. If we multiply these 3 factors together, we would get the original polynomial. So if we divide by 2x minus 3, we would get x squared minus 4. Very similar to this. I could factor 12 into 3 and 4. In other words, 3 times 4 would equal 12. And so when I'm doing division, that's what I'm doing. If I'm doing 12 divided by 3, the result is 4. Noticing, though, that the 4 could still factor down. So division and factoring are slightly different, but we want to understand that relationship, just like we see it here. Okay, so now we are going to actually divide polynomials using long division. There are a couple things that you need to check for. I'll leave myself a little more room. There are a couple things you need to check for before you get started. One of them is that if my highest degree here is 3, that I have every number consecutively moving downward, and I have a term for each one of those. So what do I mean? Well, this one says x to the third. My next term has to say x squared, x to the first, and technically this is x to the 0, or considered my constant. And since every one of them has a term, I'm good to go. If we don't have that, you'll have to put one in there, and it will be a 0, but you don't want to skip any of those. So let's write this out. We have 2x cubed minus 6x squared plus 5x, and then minus 20. What am I dividing by? X squared minus 5. Okay, so similar to our long division here, I'm trying to create a number up here that will allow 4 to go into that 6. So I'm really doing a division. 6 divided by 4 is 1, and then some, and we have a little remainder, and that's where our subtraction comes in. But I think of this a little bit differently. Technically speaking, I should be doing 2x cubed. Okay, you'd use the first term here divided by the first term here. And when I do that, you'll see that the 2 remains because there's a 1, and then we still have an x. And so up here, I would put 2x, and I would put it right here. And if you like to do it that way, that is fine. But I think of it a little bit differently. Instead of doing 12 divided by 3 equals 4, I think of it as 3 times what gives me 12. So I kind of do a multiplication in some ways in my head. And so I would say x squared times what gives me 2x cubed. And that answer would be 2 to get that 2. And then an x so that my x squared can become x to the third. Either way is fine. Once you have that number up here, you need to take this and you need to multiply to x squared. So 2x times x squared should give you 2x cubed. And that was by design. We want those to be the same. But you also have to take 2x and multiply it by negative 5. So now we get negative 2x times negative 5 is actually negative 10x. Okay. You'll notice I put it here because those are the like terms. I about put it here, and that would have been a mistake. Now, just like long division, we do a subtraction every time we find our new product. Since this is a product consisting of more than one term, I need to subtract every term individually. And if you subtract a negative, that's actually like adding. So what we do is we go through and we change the sign of every term here. This was positive 2x cubed, now it's negative. This was negative 10x, now it's positive. And then combine downward. So now we have this, nothing, because 2x cubed minus 2x squared cubed is nothing. Bring down the negative 6x squared. Add those together, because that's now a plus, and we get 15x, and then bring down your new term. Okay, do this process again. Take x squared. What can I multiply x squared by to get negative 6x squared? Well, hopefully you realize that that answer is negative 6. Take the negative 6, distribute it. So negative 6 times x squared, negative 6x squared. Negative 6 times negative 5, positive 30. And notice it goes underneath here because those are both constants. Remembering that I want to subtract these things, I'm going to change every sign. And hopefully the first term will eliminate. Negative 6x squared plus 6x squared is nothing. This has no term that adjusts it, so we leave it as 15x. And then negative 20 and negative 30 would give me negative 50. I have no more term to bring down, which means this is what we call a remainder. So a couple things to take from this. First of all, x squared minus 5 is not a factor of this polynomial because we had a remainder that exists. Think about that. If I were doing 12 divided by 5, we would get 2, because 5 goes into 12 twice. 2 times 5 is 10. And when I subtract here, I have a remainder. And we used to write it as like R2, 2 remainder 2. Then we learned to write it as 2 over 5 because 2 is still being divided by this 5. And so we read that as 2 2/5. Well, because there's a remainder, that means that 5 is not a factor of 12, not like 3 or 4 where there wouldn't be a remainder. So because there's a remainder, this is not a factor of this. Now my quotient, my answer, will be written similar to how I had it up here with that 5. This is how you write it. You put 2x minus 6, that's this part. And then this is a positive remainder, so I'm going to put plus. And then you put your remainder as your numerator. And you put your denominator, your divisor, as your denominator. Okay? And this is the quotient of this division problem. Now that's a little messy to start because remainders are a little tricky to start with. Sometimes there's no remainder, and we want to see what that looks like. So hopefully we'll see if this goes into it evenly. We're going to take this polynomial, and we're going to divide it by this trinomial. Let's see what that looks like. Again, make sure that we have every degree accounted for, starting with 4 and working down. So here's what I have. 3x to the 4th plus x cubed minus 17x squared plus 19x minus 6. Okay, and what am I dividing by? I'm dividing by this trinomial. So I'm going to put that over here. We have x squared minus 2x plus 1. Okay, same process. I want to take this term and I want to multiply it by something to achieve this value. So x squared times something will get me 3x to the 4th. Well, 1 times something gives me 3. That's 3. X squared, since there are 2 x's here being multiplied together and there are 4 here, that means I'm missing 2 of them. So I'm going to put this as 3x squared. Now take this and distribute it to your trinomial and write your product down here. 3x squared times x squared would give me 3x to the 4th. 3x squared times negative 2x would give me negative 6x cubed. These are matching terms. 3x squared times 1 is positive 3x squared. 3x squared. Remember, I'm subtracting, so I'm going to go through and I'm going to change every sign and then work downward. 3x to the 4th minus 3x to the 4th, that's nothing. X to the 3rd plus 6x to the 3rd, 7x to the 3rd. Negative 17x squared minus 3x squared, negative 20x squared. Bring down your new term. Start this process again. How can I make x squared become a 7x cubed? We would need to multiply by 7 to get the 7, and we'd also need to multiply by x to change x squared to x to the third. Now distribute your 7x to this polynomial. 7x times x squared, 7x cubed. 7x times negative 2x, negative 14x squared. 7x times 1, 7x. Since I'm subtracting, change, change, change. Compute. These will cancel, as they should. Negative 20, positive 14, that's a negative 6. They're both x squared, and so we leave that label. 19x's minus 7x's, that's positive 12x. Bring down your new term and your last term here. Last process then. Let's figure out how can I multiply x squared to become negative 6x squared. Hopefully you realize that that answer is negative 6. Negative 6 times x squared gives me negative 6x squared. Negative 6 times negative 2x, positive 12x. Negative 6 times 1, negative 6. Since we are subtracting, change, change, change. Compute. That's nothing. 12x minus 12x, that's nothing. Negative 6 plus 6, that's nothing. So for this problem, we had no remainder. So the first question says, determine if this x squared minus 2x plus 1 goes evenly into this polynomial. The answer to that is yes, okay? Which means x squared minus 2x plus 1 is a factor of that polynomial. So I'm going to write this out. My two factors so far is x squared minus 2x plus 1, and my quotient, wrong button, my quotient, 3x squared plus 7x minus 6. These are both factors of the original polynomial. One thing we have to do, though, is they say, if so, try to factor the divisor, that's this, and the quotient, that's this, further. Since we have x squared, it looks like maybe this will factor. This is a trinomial. From the earlier part of this chapter, we should remember how to factor this. We have x and x to give me the x squared. Factors of 1 that add to give me a 2. There's only one pair of factors for 1, that's 1 and 1. And if I add 1 and 1, I do get 2. Since it's a negative 2, they're both going to be negative. This is factored. This one might factor as well, but I see this 3 at the beginning. That makes it a little more difficult for me. We're going to have to do this slide and divide. So let's try factoring x squared plus 7x. And then instead of doing minus 6, we're doing 3 times that. It'd be 18. Let's factor this the same way as we did the divisor. We should get an x and an x. Factors of 18, let's subtract to give me 7. That's a 9 and a 2. Since the 7 is positive, put a plus on the 9 and a negative on the 2. Now these are not the factors of my original quotient. These are the factors of this polynomial. I slid that 3, multiplying it into that 6. We need to divide by that number on both of these. And so my factor will be x plus 9 divided by 3 is 3. And since this one doesn't divide out, we take the 3 and we write it as my coefficient for my x, leaving my numerator as this constant here. So this did factor into x plus 3 and 3x minus 2. This is a factor, this is a factor, this is a factor, and this is a factor. Those are all 4 factors of the original polynomial. And here's how it should be written. Since x minus 1 was a factor that showed up twice, we're going to write it as x minus 1, but then we're going to show its quantity by using an exponent, and then these 2 factors to follow. This would be the final and complete factorization of the polynomial 3x to the 4th plus x cubed minus 17x squared plus 19x minus 6. And we wouldn't have had a real good way to factor that otherwise because it's a 5-term polynomial. Lastly, yes, we have a factor theorem. It says for a function f of x, the factor x minus k exists if and only if the function of k equals 0, okay? Now, in other words, more simply said, what it means is if I were to plug in, like if my factor says x minus 3, if I were to plug in a 3, so if I did f of 3 and the result was 0, then that means x minus 3 is a factor. And it says if and only if, which means that this is a reversible relationship. So if 5 is a solution, by the way, this indicates that 3 would be a solution to that function. If 5 is a solution, we're saying that like f of 5 equals 0, and we can determine if that's true by doing a division and determining if this polynomial is divisible by the factor, not 5, but x minus 5. Okay, that's the relationship we need to get a hold of. If it says x minus k, then k is a solution if x minus k is a factor and vice versa. So since this says we want to know if 5 is a solution, let me rewrite this in words. If 5 is a solution, then that must mean that x minus 5 is a factor. Okay? Remember, in order to be a factor, we want there to be no remainder. So that's what I'm going to do. I'm going to divide x minus 5 and see if there is a remainder or there is not a remainder. That will determine whether 5 is a solution or is not a solution. Okay, last process here. Take x. How can I get x cubed? Multiply by x squared. X squared times x is x cubed. X squared times negative 5 is negative 5x squared. Subtract, so change your signs. X cubed minus x cubed, nothing. 6x squared plus 5x squared is 11x squared. Bring down your new term, negative 8x. How can I multiply x to become 11x squared? You need to multiply by 11x. 11x times x is 11x squared. 11x times negative 5 is negative 55x. Subtract, change your signs. So now this is a negative 11x squared. And when I combine that with positive 11x squared, that's nothing. Negative 8x and a positive 55x will give me positive 47x. Bring down the 15 and do this again. X. How can I multiply to get x to equal 47x? Multiply x by 47. 47 times x gives me 47x. 47 times negative 5 will be negative 47 times 15, 705. And when I subtract, okay, changing my signs, this becomes 0, this becomes 730, which means my remainder exists. Okay, this is my remainder. So since x minus 5 is not a factor, so 5 is not a solution. And that wraps up the lesson. Hopefully that made some sense. If you have any questions, let me know.